Now, in this video, we will discuss uh, how we are identifying the risk in the format in the risk identification for a form. Okay, so in the review form, sorry, identification form, risk identification form, we have this cause we are writing here, event we are writing here, and the effect we are writing here, and it will be here it will be mitigation measures, and here's the table. Here we are scoring the risk, by which we are scoring the risk. So step 1 is first cause. It has to be revisited during the life of the risk for to identify the most appropriate action going forward. So always it is reviewed, this cause, and a description of the actual event that could potentially happen. That is the event, and the effect is the what a description of the effect company should endure or suffer in when the event actually happen. And what is for this and step 4 is assessment of the likelihood. Fifth one is assessment of when there is time effect. Uh, So it is always likelihood in the impact. This is the time impact. Step 6 is the which impact? It is the performance impact, and 7 will be the here. What will be the time cost? Time cost performance. This is the cost impact, and this will be the performance impact. Here is the performance impact. So um, after step 6, step 7 is the initial view of the mitigating actions that are required to be managed by the risk. It was developed and amended as a risk goes on the process by SRC or RMC as appropriate. Once this form is completed, it should be submitted to the manager and associate chair, risk specialist, or email to risk@transco.ae. Now, risk analysis. So here we have written as an example in the form. So this was a risk and management of diversion of a flow of existing uh, facilities. But there is a risk because improper management of the diversion of the flow of the existing facilities. It will result in an additional cost due to overpumping works, obstructions related works. So these are the cause, event, and here it will be effect. Effect. So we discuss the effect, cause, and event, and this will be the effect. It will result in additional cost due to overpumping works and the destruction of its relative works. So what will happen? This is the likelihood. Likelihood is this is impact. This is time impact. It is 3 into 2. That is 3 into 2 equals 6. This is cost impact. That is 3 into 5. Cost impact. It is 15, and this is the performance impact. Minor shortfalls in the desirable requirements. That is 3 into 2 equals 6. Now this is the mitigation, non-mitigation method that to be lies with the transco and them to obtain proper PTW to start a diversion of work. Diversion work. PTW is the problem. So this is the step 7 is the mitigation measures. Now we have all these things. Now the major score is 15. So it is we are going to check the risk register. There's a table from 1 to 4, 5 to 8, 9 to 12, 13 to 16, 17 to 25. Insignificant, like no action required. Acceptable, 5 to 8 is acceptable, acceptable without any special control measures. Tolerable, accepted with adequate control measures. Undesirable, shall only be accepted when the risk reduction is impractical. Shall only if reduction is impracticable, then it is undesirable, then only accepted. And this risk shall be eliminated, 17 to 25, like this. So this is what we discussed as an example, this one. Management of diversion of flow of existing is coming in the risk event. This was the cause, that is improper management, and effect was results in the additional cost due to over pumping and obstruction of relative works. This is the likelihood, 3%. 3% mean 3 is a 25. Here it is written clearly. It is a 25 to 50% chance. So it was 3. 5 was a which matter cost impact. 5 was a cost impact. That is a very high. That is a 10,000 1000 into 1080 to 900,999 1000 AED. It is very high, and the score is 5. So, so now we will continue with the risk analysis. Okay. So these are a checklist for analyzing the risk. Is the risk correctly described? Is the cause, event, and effect correctly completed? Is the probability realistic? If the timing of the risk realistic, has the impacts fully identified? Are the mitigating appropriate if completed? Have the same or similar risk has been previously identified? These are the checklist of the risk analysis. If risk passes these RFI checks, it is entered in the risk register by the risk specialist, and it is at this point it is reviewed to identify if it needs escalation. If the risk score scores 16 or more, the risk is escalated immediately to the chair of the RMC for information sanction of the required action as appropriate. Now, the risk evaluation is the preparation of mitigating actions and responses to the risk identified. Now, the risk treatment. So, we will continue with the risk treatment. So, there are 1, 2, 3, or 5 methods: treat, transfer, tolerate, terminate, and share. The treat means we are doing mitigating actions to minimize the impact. So that is treat. Just put in place mitigating actions. What is transfer? It is transferring risk impact to another party, most commonly through insurances, but it should be as per the contract agreements. Tolerate, accept the risk impact and do nothing. Cost of the mitigating actions may be more than the may be suppose in some cases the cost of mitigating actions will be more than the risk impact itself. So in this case, we are tolerating the risk. Terminate. Removal of the risk in its entirety. And share, where the cost of the mitigating actions are shared. For example, should the risk occur, should the risk occur, the then the costs are also will be shared. Cost of mitigation will be shared with the contractor and the client. So now here we'll learn little more about the termination. Okay. So we'll discuss a little more about the termination. Termination is one of the four T's in the risk response strategies. That is four T's and S. Actually, terminate, treat, transfer, and tolerate and share are the five uh, risk response strategies. In this, removal of the risk refers to, or termination refers to a strategy of risk avoidance. Means it is we are eliminating the risk entirely by removing its cause. It's a proactive approach used when the potential negative impact of the risk is unacceptable and the mitigation or the transfer is also not viable or cost effective an option. So what is the key aspects of the risk termination? But there are some key aspects of risk termination. What we are doing here, we are removing the source of the risk before it can affect the project, and also it's a strategic decision making with a this kind of risk removal is reserved for threats with high potential impact or high probability of occurring. Means deciding that the potential negative consequences outweigh the any potential benefits, but there is a lot of loss of potential opportunities because any positive potential positive opportunities associated with the activities also eliminated. For instance, avoiding a high risk but a potentially lucrative project eliminates the possibility of a large returns that it could have bought. Okay. So examples in a construction project management, altering the project plan is one of the example. A contractor may change the project plan to avoid a certain risk. For example, deciding not to work with a subcontractor with as a history of poor performance eliminates the risk of schedule delays and quality issues. Modifying the design of or material. If a specific building material is known to have high risk of failure or possess a health risk, project manager could opt out and of safer alternative material, thus eliminating that risk entirely. Third one is avoiding high risk areas. For a company may decide to turn down a project in a politically, environmentally unstable region to avoid sufficient financial and logistical risk associated with that location. That is avoiding high risk areas. Then changing the construction methods. A project may decide against using a novel or unproven construction technique that carries a high risk of failure or unforeseen problems. Instead, they choose more traditional, safer method with a non-practice record. Cancelling a project segment. If a specific phase of the project is determined to be too risky to proceed with, the company may opt for abandon that portion of the risk entirely. So we have some more risk in the planning engineer side. Okay. So now we will continue with the risk avoidance. So what is this risk avoidance? It is a proactive risk response strategy. It involves eliminating threats entirely by changing the project plan, objectives, or execution approach. Instead of reacting to a risk, they arise or trying to mitigate the impact. Risk avoidance addresses the root causes to ensure the risk cannot happen. So it's a response strategy where project team acts to eliminate the threat or protect the project from this impact. For example, faces the you have a risk of weather disruptions. So his examples are suppose a risk of weather disruptions during crane operations. So we can avoid this risk by rescheduling the lifting operation to a lesser windy season or reducing the project to minimize the reliance on cranes. Also, in areas where the local regulations may delay the obtaining construction permits, risk avoidance involve hiring a specialist consultant familiar with the local regulatory environment. This expert can ensure all documentation complete submitted early, reduce the chance of delays. Alternatively, project team prioritize regulatory submissions during the initial planning phase, thus allowing time for approvals without impacting the critical path. These are the examples of risk avoidance. So, how it is different from other risk response? So, as we discussed before, there are four methods of four TTEs: terminate, transfer. What are these? Terminate, transfer, treat, tolerate. These are four T's actually. In these four T's, it is different from risk avoidance. Termination or risk avoidance is different from other. In the risk mitigation, risk mitigation reduces the likelihood or impact of a risk, but not eliminate it. For example, installing windbreaks for crane operations reduce the wind effects, but does not remove the risk entirely. Risk transfer, that is shifting the responsibility for managing the risk to a third party through insurance, warranties, or subcontracting. But the risk still exists, but is no longer managed directly by the project team. Then risk assessments acknowledge the risk without taking proactive measures to address it because it is very costly for these mitigation actions in the, and the risk impact itself. So it often involves preparing contingency plans for managing the consequence of if risk occurs. On the other hand, avoidance is unique in its goal to completely remove the possibility of the risk, while the mitigation or transfer reduces or shares the risk avoidance ensures it is no longer poses a threat. This is the first choice strategy when the risk is judged to be so severe and costly to address in another way. What do you get from risk avoidance? This concern requires identifying the high risk, high priority threats early and incorporating actions into baseline to eliminate them. Focus on root causes. How it is working. The avoidance works by removing the conditions that create the risk. For instance, if a process is located near a near bank prone to soil erosion, the risk of soil instability can be avoided by adjusting the project's layout to place the key structures further from the river or by reinforcing the foundation in the less risky areas. These changes eliminate the possibility of delays and safety concerns caused by soil erosion. So, research investment is a result of proactive approach. This evidence can demand additional resources input, including change to design, scope, and even procuring alternate equipment. While these measures increase initial cost, but even lead to significant long-term savings by avoiding disruptions. Okay. So here is one example: risk of underground utility damage. So one project we have this underground utilities where water mains, gas lines, electrical cables, etc. The risk of this damaging these utilities are high due to incomplete or outdated plans and difficulty of precisely locating the lines. So what are the strategies? We can transfer the risk by placing liability on the subcontractors. We use mitigation measures like that means treat using putting mitigation measures like hand digging or using mechanical excavation with caution, using trial pits, etc. Third thing is a risk avoidance by conducting a detailed groundwater survey using advanced ground penetrating radar or similar technology before excavation begins, which is good actually. Transferring the risk that involving subcontractors does not protect the project from protection delays and cost escalation due to utility outages. Second thing is hand digging or using mechanical excavation. It reduces the likelihood of damage but does not eliminate it. But here, detailed underground survey, but it is therefore the utilities are accurately marked, mapped and marked. So excavation to proceed with the risk of damage. So avoiding by this pre-excavation surveys eliminates the risk of damage entirely, saving time and cost. But the initial costs are high, but it is when compared to the long run benefits like avoiding delays, it is more it is useful actually. So second is building on an unstable site. So second example is uh, suppose a construction site have identify with having a highly compressible soil with a significant risk of settlement as a under load of the plant structure. It could lead to foundation failure, structural cracks, and long-term maintenance issues. So, if you are using mitigation such as ground improvement techniques like soil compaction or chemical stabilization, it can reduce the likelihood of the settlement, but it cannot fully prevent it for extremely poor soil conditions. And transferring the risk through contractual warranties does not solve the core issue, might lead to construction delays and costly repairs. So avoidance in this case means redesigning the foundation to use deep piles, which eliminates the risk of settlement. So it ensures a stable structure by completely removing the risk of soil-related failures, even though it may require more advanced foundation engineering. Third one is third example is a rain disrupted constructed activities. A construction project may require extensive outdoor activities such as concrete pouring or structural assembly during the rainy season. The heavy rainfall increases the risk of poor quality of workforce, material damages, and schedule delays. So we have, as per our strategies, mitigation strategies like treat, the installing temporary shutters or rapid curing materials can reduce the impact of rain, but still leave the project vulnerable to the weather-related disruptions. So accepting the risk rework increase cost and prolonged timeliness, and transferring the risk through contracts does not address the underlying issues of weather interference. So best avoiding is the rescheduling the critical outdoor activities to drier months, ensuring consistent progress and maintaining high risk standards. That's by adjusting the time frame removes the risk entirely and proceed smoothly without weather related disruptions. So now we will discuss monitoring and review. So with many strategies and processes within the company, risk management framework is subject to continuous improvement. ഒന്ന് മിണ്ടായിരിക്കാവോ? Continuous improvement to continue. Will be responsible for the governance of the developments of the framework on an ongoing basis. So risk management is a relatively new activity in the Transco. It will need to be reviewed and revised as the approach to the risk management with the company matures. It will be reviewed at least annually. So this risk management is a new activity and it should be reviewed. Process will be reviewed and revised uh, as the approach the risk management within the company matures. This will be reviewed at least process will be reviewed at least manually to ensure it for the purpose, and any changes are documented by the risk specialist within the B